In this video, we're going to dig a little bit deeper into the idea of distillation, and in particular focus on distillation curves, which help us understand the relationship between the volume of distillate that we're getting right over here and the temperature at the top of the distillation column right over here. Not the temperature of the hot plate, not the temperature of the solution, but the temperature at the top of the column right as our vapors are starting to enter into this condensation tube. That's what this thermometer is measuring. So let's go back to a solution that is 10% ethanol. Ethanol has a boiling point a little over 78 degrees Celsius, say approximately 78 degrees Celsius. And let's say that the rest of it is water. So it is 90% H2O, which of course has a boiling point of exactly 100 degrees Celsius. That's how the centigrade scale was determined, with the boiling and freezing points of water. And so if we're going to try to distill as much ethanol as we can, as pure of a sample of ethanol as possible, we're doing fractional distillation here, where as we start to increase the temperature of the hot plate and we try to get this solution to boiling, in theory, you'll have vapors even before you get to a boiling temperature. But to really overcome the atmospheric pressure and start to get a lot of vapors in here, you want to get this solution to boil. And then the vapors start coming up this column. Now, the proportion of ethanol in those vapors is going to be higher than 10% because ethanol has a lower boiling point. And it's going to go through multiple condensation and vaporization cycles as it condenses on different parts of the surface area on the inside of this column. We're doing fractional distillation. In fractional distillation, this column is engineered to have a lot of surface area. There's multiple ways to do it with bumps or wires. And so you have multiple cycles. So over time, this is boiling. The temperature up here is going to increase. But when the temperature is below the boiling point of ethanol, you're not going to get that many vapors up here. So I'm going to start at the temperature 70 degrees Celsius. Obviously, I'm not showing the entire scale here. And you're not really getting a lot of distillate. But then you get to about 78 degrees Celsius. And now a lot of the ethanol vapor is making it up here. Remember, it's multiple cycles. So by the time you get to the top, it's fairly pure ethanol. It's a very high proportion of ethanol. And so it's making its way up there, and then it's making its way into this condensation tube, getting cooled down by this water that's flowing through the outside, and then condensing as distillate. And so at that temperature, we're starting to collect a lot of ethanol right over here. And this is ethanol's boiling point, that's 78 degrees. And then once a lot of that ethanol has left our solution and has vaporized, it's now been condensed as distillate, you can imagine you keep having to turn up the temperature on our hot plate, because as the ethanol vaporizes out of it, the boiling point of the solution is going to get closer and closer to the boiling point of water. But the temperature up here isn't going to get a lot higher than the boiling point of ethanol, because those hot ethanol vapors are all being released into this condensation chamber and then being cooled down. But once you've depleted a lot of the ethanol and you're heating up your solution, the temperature is going to have to increase a lot more for what's now disproportionately water vapors to stay in vapor form to get up to the thermometer right over here. So you're not going to produce a lot more distillate until you get to water's boiling point. And at that point, the water vapors are making it up here in significant quantities. There would have always been maybe a little bit of water vapor here or there, but in significant quantities that you can really notice. And then they're making their way into this condensation tube, and then they too are condensing as distillate. So at that 100 degrees Celsius. Now, if you wanted to separate the ethanol from the water, which is arguably the point of distillation, what you would do is you would keep one bottle to connect the ethanol over this period right over here. And then once you see that you're not collecting a lot of more distillate and the temperature is starting to go up, you would then replace the bottle with another bottle so that you can start to collect the water right over here. Now, there are situations where you're presented a distillation curve like this and asked, well, what are the boiling points of the different things in the solution? Well, there you can look at these flat parts right over here and you say, okay, that is the boiling point of the first thing, boiling point number 1. In this case, it is the ethanol. And then this second plateau is the boiling point of, in this case, the water. And you could actually go the other way around. If you're like, what's going on? What is inside of this? You might be able to determine it by looking at the actual boiling points. Now, what I just showed you, this is fractional distillation. You might be wondering, what about simple distillation? Simple distillation does not have those repeated cycles of condensation and vaporization, so you don't have as pure of a vapor of your lower boiling point substance early on. So what happens with simple distillation is you have both water and ethanol vapors that need to get up here. So you really don't start condensing and getting those vapors until the temperature is the boiling point of the mixture of vapors up here. It's still going to have more than 10% ethanol than water, because ethanol has a lower boiling point, but it might look something like this, where it takes a higher temperature to start seeing distillate, and these plateaus aren't quite as pronounced. So it might look something like this, because the whole time the vapors at the thermometer are going to be more gradually transitioning between ethanol and water. So from a simple distillation curve, it's much harder to pick out the boiling points of the constituent substances.